All right, welcome back. Babel really is an amazing accomplishment by an open source community, and an example of another kind of declarative, plugin-driven piece of software, like Webpack, that pushes JavaScript forward. Now we're going to start right where we left off in the Intro to Babel episode, but if you need to catch up, check out Babel 2. Let's get a little more into how Babel works by adding polyfills to our codebase to extend the browser's current capabilities and run features that are still being debated in the standards committee. Really cool way to evolve a language. Now, let's add something that's definitely going to be in the language. Inside our main.js, let's add async await. So in our Babel RC, let's add another plugin. The plugin is async to promises. Now let's install the package. We're going to npm install Babel plugin async to promises. So now if we run this in the terminal with Babel source main, we see that Babel returns promises. It turns the function into a promise then function. Let's change the code further. Let's say we had a console log after this async await. We run it again. We see that we have the await calling return from the first promise. The then function will call anything placed after that. You can see Babel is parsing our code and returning new functions that define how the code should flow. This shows the true power of Babel, and that Babel can understand our code. Async await syntax is working its way into many evergreen browsers, but at this point, it's still part of the ES17 spec. Either way, in IE11, we'll need to include a polyfill to run even the transpiled code, since IE11 doesn't understand promises. So in our terminal, let's install the polyfill now. We're going to npm install Babel polyfill. Now in our Webpack config, in the entry, let's add that package, Babel polyfill. Because this is an array, Webpack adds the Babel polyfill package before our own code. Now let's see how that works. Let's run npm start. We can see our main bundle.js is quite a bit bigger and includes the polyfill code. To reduce the size of this, it really is best to use only the exact polyfill you'll need. So let's change the main entry again. Instead of polyfill, we'll include only the promise library, which is in core.js. So if we run it again, we see that quite a bit of code has been taken out, but the ES6 and ES7 promises are available in the code. Now this extra polyfill code will only be run if they're not already implemented natively in the user's browser. They're still going to need to be shipped to every browser in one bundle. Let's restore the main.js to its former self. We've seen how we can add Babel features one at a time with plugins, or we can use presets to include all the features of a particular year or a particular way of working. There's a preset for React, which compiles JSX for you. Presets make setup easier, and the env preset is the current preset that works best in most situations. So let's wrap up our overview of Babel and set up a full ES 2017 feature stack so we can finally start coding our project the modern way. In your terminal, npm install Babel preset env. Now in our Babel RC, let's take out these plugins and replace it with presets, which is an array, which takes another array. The first argument of that array is env, and the second argument is an object of options. We're only going to include one option, debug true. When we rerun the development server, we see debugging information. env automatically installed all of these plugins to give us the full range of JavaScript ES17. If we add another option, targets, we can change this default. We're going to target browsers, the last 2 versions. Behind the scenes, Babel is checking the compat table, which can be found at this URL. It determines the current state of browser features automatically. So if we add a target to our Babel RC, Babel's going to give us the plugins we need. There's one more thing we need to make Babel complete. We're going to add another plugin. Transform runtime. And in our main.js, we're going to include, before everything else, the Babel runtime regenerator. Let's add some more 2017 code. So if we have an async function, we can give it some arguments. We can denature the object. Finally, we can use those objects. And at the end, let's call the function, giving it values for our argument. Lastly, let's add the package. npm install Babel plugin transform runtime. Now let's start our server again. Now let's see what this becomes. If we npm run build, outputs our main bundle. Inside our dist directory, let's search for the word future. So you can see where we're running the function here. And the function has been completely transformed into a generator. Feel free to continue to use ES17 features and see what they look like in the final bundle. It can be kind of confusing, but the idea is that Babel knows what it's doing. And if you open this up in an older browser, the older browser is not going to error. Transpilers are a fascinating part of the JavaScript evolution and allows for lots of experimentation with the look and feel of a new syntax before the makers of the engine commit to the implementation. If you got lost along the way, here's where the final code resides. In the next episode, we'll ditch the Webpack dev server to serve our files from a server we'll build using Express and some clever middleware. We'll customize our output and get set up for a real full-stack Node app. See you there.